So what exactly is structured programming? Structured programming is a method for designing and coding programs in a very systematic and organized manner. This is very powerful. If you learn structured programming, then when it comes time to putting together a programming project and putting together an application, it's really, really going to make a huge difference on how fast you can put the project together and how quickly you can troubleshoot it. Okay? It combines the principles of what is known as top-down design. This is also huge because you start with the big stuff that you want to see done, and then you work your way down to the little things that you need to do to get the big stuff done. All right? Which means that you're going to be doing, or you're going to be implementing modularity, and you're going to have submodules. Okay? So we have three main structures that we're dealing with. One of them is called the sequence structure, which you guys have played around with. You did input, you did a formula, you did output. You followed a sequence. Okay? Another one is called repetition. Okay? And a repetition structure basically is maybe like a loop. You might have to do something over and over and over and over again. And then finally, we have selection. Okay? We need to redirect the code into different places. All right? So sequence, repetition, and selection can all be expressed in pseudocode or with flowcharts. Okay? So what exactly is a flowchart? A flowchart is an array of symbols that helps us to know what the program is doing. Okay? We have a symbol that is known as a terminator. Sometimes this is a in some flowcharting programs, this ends up being a circle, but it's typically, this critter right here. Terminator indicates the beginning and the end of a program or module. This shows the process, like evaluating a formula or something along those lines. This symbol has to do with input or output. Sometimes they put a little arrow right here pointing inwards, letting us know that it's input, and then a little arrow pointing outward, letting us know that it is output. Down here we have a decision. These critters, all these together, form pretty much every single thing that you need to actually flowchart a program. So let's talk a little bit more about control structures. Okay? In the 1960s, computer scientists proved that there are only three basic control structures. They're also called constructs. Boy, isn't that a word for you. Don't let that word scare you away, because a lot of people do refer to it. A lot of people do use that word. This is a particular construct that I'm working under, or something along those lines. It just means that this is the idea that I'm working under. That's all it means, okay? So you can, if you want to, implement any program or algorithm with really only using three basic control structures. One of them is sequence, where we, as I said, do things in sequential order. It is the simplest of all the control structures because you just start at the beginning and you just continue until you're done. Selection means that what we're going to do is we're going to decide what commands we want to execute based upon the current state of a variable. So for example, if we're trying to decide if a number is less than or equal to 0, print the message can't divide by 0. Or if the number is greater than 0, print the message, you done good. I will go ahead and do the division. Or just simply do the division, whatever you want. Okay? So we're selectively executing statements based upon the condition or the state of an existing variable. Repetition, this is also known as a loop. All loops need some kind of a stopping condition. We need to be able to get out of the loop, right? That's one of the fundamental issues on algorithm design. It has to be able to stop. So all loops are going to have some kind of a stopping condition. Whether you say for x equals 1 to 5, well, guess what? 5 is the stopping condition, isn't it? Because as soon as we hit 5, we're done. We can keep inputting information while something else is true, right? We'll learn a lot more about loops later on down the line. We'll code loops later on down the line. Every program that's out there is going to be following some kind of a programming style. After a while, you're going to get to a point to where you're going to be able to see a body of code and you're going to say, oh, I know so-and-so wrote this body of code. You're going to see it in their programming style by virtue of the type of the way in which they do their comments. You're going to see it in terms of what modules they write and how many submodules they write. Part of the process of developing your own style, though, requires a few pointers, okay? You need to start at some generic beginning, and the generic beginning is this. Number one, we write modular programs, okay? Whenever possible, write a modular program. Number two, whenever we write a variable, we always use descriptive names. And we're going to use the naming convention that is typical of that programming language. Most programming languages use camel case. So let's say that I want to create a camel case variable whose name is literally descriptive variable names. I would have lowercase descriptive, and right up against it with no space I would have variable, but the letter V would be uppercase. And then I would have up against that names, and the letter N would be uppercase. That is known as camel case, okay? Always provide a welcome message for the user and some kind of intent of the program. This program calculates Fahrenheit from centigrade, and then you give a prompt. I can't tell you how many times I've had somebody hand me in code that when I launch the program, the cursor blinks at me. I have no idea what it's looking for unless I halt the program and then go in the code and read the code. And hopefully there are enough comments there to clue me in as to what is really expected from the user, okay? You'll want to, of course, identify the program output. A lot of you guys that did the centigrade to Fahrenheit program did exactly that. Okay, you said so many degrees centigrade is equal to so many degrees Fahrenheit. There was absolutely no question what was being communicated there. Okay, and then lastly, document your programs. Always document your programs, and in truth, you could lose your job over this, okay? Documentation of a program begins with comments and ends with actually creating the documents themselves that you might distribute. Now, what's really cool about this whole documentation process is with some programming languages, if you do your comments correctly, you can run a little program against the code that you've written, and it will produce all of the documentation that needs to be shipped with that program. If you were, for example, programming in Java, well, there's a language called, or an application called JavaDocs. And if you code your comments correctly, this application will scan through all of your Java code and it will create HTML web pages that document your code, your application, which is really cool. Okay, so we've covered that much. Let me see about putting together a modular design in Python so that you can get an idea of what that's all about.